Alright class, so this video is about increasing and decreasing intervals. I just want to review what an interval is. When we're talking about intervals, we're talking about between two numbers, okay? So if I want to talk about on the x-axis, if I want to talk about numbers between, let's say, 2 and -3, I would say the interval between -3 and 2. So remember, when we're writing an interval notation, we just give the first number and the last number of the interval that we're interested in, okay? And also remember, for interval, we either use an open bracket or sometimes we use a closed bracket if we're including it, and that depends on the problem. Okay, so that's just a quick review on intervals. We did a full lesson on it a few days ago. Alright, so if you have any questions about that, just look over that lesson, or you can let me know if you have questions. Okay, so when we're talking about increasing and decreasing intervals, we're looking at a function. We can say that a function is increasing when the y value increases as the x value increases. What that means is, if I'm going from left to right, okay, if I'm starting from the left on my x-axis and I'm going right, my f of x is going up. So meaning that it's gonna go look, when we graph it, it's gonna look like it's going up. Okay, and then a function is decreasing when the y value decreases as the x value increases again. So again, I'm looking at my x value going from left to right, and then if it's decreasing, my y value is going down, so it looks like the function is going down this way. Sometimes I have students say, well, the function is increasing if I go this way, going from right to left. But no, when we're talking about increasing and decreasing, we're only looking at the function going from left to right, okay? And then in this class, we're interested where the function is increasing using intervals, which we just talked about. If we want to talk about where the function is increasing or decreasing, we just give the first and last number on the x-axis. I can't emphasize this enough. Only on the x-axis, okay? And then we'll get some examples coming up. So let's start by labeling this graph we have here where the function is increasing and decreasing, and also label the turning points. Okay, to me, I'm going to highlight this turning points because this is important to determine. It just makes things easier to determine where the function is increasing or decreasing. So a turning point, like for example on this right here, is a turning point, because the function is turning here. Same thing with here. This is a turning point, and over here. So these are called your turning points. Sometimes turning points are called maximum and minimum values, or yeah, that's one way we can say it. And then, but for our class, for this purpose, we're just going to call them turning points. And just know that that's where your function changes. If the function is increasing, it changes to decreasing, and vice versa. Alright, so again, I said I'm going to start from the left of the function, so I'm starting from here, and then looks like I am going down, right? So I can say that here my function is decreasing. And then here my function is increasing, because as when I put these, I like putting these arrows, it's increasing. I like to note that here at a turning point, it's neither increasing or decreasing, okay? So just remember that. Over here, and at the turning point, it changes from increasing to decreasing over here. And then my function is increasing again here. Okay. All right. Now we're going to go through some examples. This function, does the function appear to be increasing or decreasing? It's increasing because it's going up. This function appears to be decreasing because it's going down everywhere. And then here, the function seems to be increasing and decreasing because it's going down here, up, down, up. So it's doing both. Okay. All right. Here, this is where we need to write our answers. It says state the interval or intervals where the function is decreasing. Okay. So I'm going to start from the left, and I'm just going to mark it here. So if I start from the left, yes, it is decreasing here. So I'm going to mark it. And then at my turning point, it changes directions, but I'm not interested in increasing. I'm only interested in decreasing. So it increases here, but then at my turning point, it starts decreasing until this other turning point here, and then it starts increasing. So this is where it's decreasing, but then I need to write this in interval notation. So I simply start by writing a parentheses. Okay, let me just get my mark. Parentheses, comma, parentheses, and I'm gonna write my beginning and my ending. So it looks like it's starting here on my x-axis. I want to say some decimal, but since I have an arrow here, this means that it's starting to decrease from negative infinity until on my x-axis at 1. Okay. And then it's also decreasing here. Remember, in math, we use this union symbol to represent and. And then we're going to put another set of parentheses and then say that it's decreasing again from x equals 3 until x equals 4. Okay? All right, where is my function increasing? So again, this is decreasing here. Here's my turning point, so here's when my function is increasing. Here's my turning point, it's decreasing. Here's my turning point, increasing here. So it's increasing at these two intervals. So just to write this, I start with the open bracket. And the reason I'm never going to use a closed bracket on any of my increasing and decreasing problems is because at the turning point, at that point, it's not neither increasing or decreasing. So at least we know that we can just use parentheses. So it's increasing, starts increasing at 1. Don't look on the y, only look on the x. At 1, and then it stops increasing until 3. And it starts increasing again at 4. And then doesn't stop increasing, it goes on till infinity. So I'm just going to write infinity here. Okay. So we have more examples here. I'm just going to do 6 and 7, and then I'll have you guys try the rest of them in your packets. So let's look at this. Where is my function increasing and decreasing? So I'm going to start from the left. Here, it looks like my function is decreasing. Starts off by decreasing until my turning point here, which is at negative 1.5. So I'm going to say it's decreasing from negative infinity to negative 1.5. And then at my turning point, it starts increasing until here. So it increases from negative 1.5, that's my turning point, until x equals 0. Okay, and then it starts decreasing over here at my turning point. So union, it starts decreasing again from 0 at my turning point, and it stops decreasing at here at 1.5. And then finally, my last interval it's increasing here. So we can say it's increasing from my turning point at 1.5 until infinity. Number 7, the function is increasing for all real numbers, true or false. I just want to write all real numbers in interval notation. It's just if we're looking at all real numbers, we're looking at from negative infinity to positive infinity, okay? So from negative infinity to positive infinity, it is going up. There's nothing I don't see any turning point. You can say maybe this is a turning point. No, it isn't, because it would turn back down, okay, if that was a turning point. So since it's all going up, we can say that yes, this is true. The function is increasing from between negative infinity to positive infinity, okay? I have more problems on this. Let me know if you have any questions. Thanks, class.